Example problem 4. Using factoring to solve a real-world problem. You're constructing a frame for the rectangular photo shown. You want the frame to be the same width all the way around and the total area of the frame and the photo to be 315 square inches. What should the outer dimensions of the frame be? Let's consider what you know, what you need, and make a plan. Well, you know the size of the photo is 11 inches by 17 inches. You also know the total area desired is 315 square inches. What you need are the outer dimensions of the frame. And a plan? Let's write the frame's outer dimensions in terms of its width, x, and use these dimensions to write an equation for the area of the frame and the photo. So, we know the total area of the photo and the frame is, well, we want it to be 315 square inches. We know that the photo itself, so not including the frame, the photo itself is 11 inches by 17 inches, and so we could quickly and easily find its area. It turns out that's not that valuable for us in this problem, but it's something we know, and those dimensions, 11 inches by 17 inches, will be useful in finding our outer dimensions. So, the height of the photo is 11 inches. If we're going to add a frame of width x, or x inches, then note the height of the frame and photo would be 11 plus x, or 11 plus 2x inches. Something similar for the width, 17 plus 2x inches. And note we want our total area of the photo and the frame to be 315 square inches. And area equals length times width. Therefore, we can write the equation multiplying our binomials on the left using a quick FOIL of first, outer, inner, and last. We find the equation 4x squared plus 56x plus 187 equals 315. Recalling that our goal is to use the zero product property to solve for x, and knowing that we are looking for an equals 0 on the right hand side, we know we need to subtract 315 from both sides of this equation. And doing so, we arrive at the equation 4x squared plus 56x minus 128 equals 0. Now we factor the expression on the left. Remember, our goal is to have two binomials, or at least two factors, equal to 0, so we can use the zero product property to solve. Now, I notice right away that all of these terms, well, they have a common factor of 2. Even more so, they look to have a common factor of 4. And so we can factor a 4 out of all three terms to make the factoring of the trinomial even easier for us. And factoring out a 4, we get 4 times the quantity, x squared plus 14x minus 32 equals 0. And now factoring the trinomial inside the parentheses, the 4 will kind of hang out there on the left-hand side while we factor the trinomial in parentheses, an x and an x for first terms, give us the x squared we're looking for. And so now we're seeking last terms for our binomials. Last terms that when multiplied equal negative 32 and when added equal 14. 2 and 16 come to mind as factors of 32 that are 14 units apart. One of those will need to be negative and one will be positive to give us a negative 32. So the 16 would need to be positive, because recall our sum needs to equal 14, and 16 minus 2 is 14. Completing the equation equals 0. And now the 4 on the outside is something we haven't seen yet in this section, but it doesn't really matter because we'll go about solving this using the zero product property just as before, and knowing that if we provide an x value that makes this binomial on the left equal 0, Let's do that now. Negative 16 makes the left binomial equal 0, and 0 times 4 is still 0, and that 0 times whatever x minus 2 results in is still 0, and so x equals negative 16 is one of our solutions. And of course our second solution, x equals 2, because 2 minus 2 equals 0. Now we should recall what x represented in the first place. X represented the width of the frame around our photo. Notice negative 16 inches makes no sense in the context of this problem. 2 inches makes sense, so 2 is our only reasonable solution. So we'll let x equal 2 and then answer the question that was posed in the problem. It said, what should the outer dimensions of the frame be? Well, recall our width was 17 plus 2x. Substituting 2 inches in for x, we'll find 17 plus 4 inches, or 21 inches. And for our height, 11 plus 2x inches. X again is 2. 11 plus 4, 15 inches. And so our final outer dimensions of the photo and frame, or the outer dimensions of the frame itself, are 21 by 15 in terms of inches. And we can write that as 21 inches by 15 inches. And a chance to show that you have got it. In problem 4, suppose the total area of the frame and photo is 391 square inches. What would the outer dimensions of the frame be? And your lesson check exercises for this section.